Hi, everybody. I'm going to split today's notes into two lessons. The first one's going to be more about notes, and then the second one will be going through finding actual Taylor series. This is where we left off yesterday, looking at the Maclaurin series for sine of x. I'm just going to pop over to Desmos quickly and show you how amazing this series is. Right now, you're looking at the graph of sine of x. And when I turn this one on, this is the series that we found yesterday. The -1 to the n is making it alternate between positive and negative. And then we've got odd powers of x and then odd factorials, x to the first and then third and then fifth and then seventh. And the same thing factorial on the bottom. So what we're looking at right now is a first degree approximation, a linear approximation. And as I increase the power, because it's going up by 2 each time, the 2n plus 1 makes it go up by 2. This is actually jumping from a first degree to a third degree Taylor series. So the value of the function, the first derivative, the second derivative, and the third derivative are all the same. We see it's actually a pretty good fit already. It looks like between -1 and 1, it fits pretty well with only two terms, the n equals 0 and n equals 1 term. And as I add more terms, we see better approximation farther out. If I go to, let's see, I've got 7 terms. I actually have a 13th degree approximation because if k is equal to 6, we've got 2 times 6 plus 1 all the way up to a 13th degree, but we see it fits really well between at least -4 and +4. And in fact, I can zoom out, and if we do the first 20 terms of this thing, we can see that it's a really good fit. We could determine using the ratio test that the interval of convergence of this is all the way from -infinity to infinity. Hopefully you did what I suggested that you do yesterday and do the same thing for cosine, but I am going to put all of these in one place for you. I put these in the category of series to know. 1 over 1 minus x, that's the basic power series that we've been doing for a few days at this point. Not much to say about this one, geometric series with the ratio of x. E to the x is the one that we discovered, I guess this was yesterday that we saw this one for the first time. I'll pause just a moment. Go ahead and pause the video if you want to stop and write these down. And we're back. And the next slide, I've got cosine and sine. We did cosine together, we did sine together yesterday. Hopefully you did cosine on your own. If you did cosine, you saw this pattern happening, the odd, even, because of the different values of the derivatives. And then these are all even power exponents just because of how cosine works. Also worth noting that sine is an odd function. You got all odd powers and factorials. Cosine is an even function, all even powers and factorials. These four I put on these two slides as series to know absolutely positively on the AP test. It will be beneficial for you to, when you see sine of x, that you remember that this is what that series looks like for reasons that we'll get at a little bit later on. This last one I have, inverse tangent, is not as crucial, but as soon as I say that this one's not a big deal, that's going to be the first year that it ends up on the AP test since the last time I said it wasn't a big deal, because that was the last time it showed up on the AP test. So I put this one here. If you know this, the chances of it being on the AP test, especially this year, are that much less. The thing that I'll point out is that this one is awfully similar to the sine Taylor series, except it doesn't have the factorials attached to it. Everything else is identical, which is crazy when you look at the corresponding graphs that they're so similar, but the graphs end up looking so significantly different. The only other thing I want to mention with this set of notes is, I'll just put this in here as well. This is matched up with what you wrote down yesterday. The Maclaurin series that you wrote down yesterday looks like this. And Taylor series, I've mentioned it in passing, but we haven't actually done any of them yet. That will be the example that I will do for you with the second video that I published today. The only difference is that instead of doing this at 0, instead of evaluating the derivative at 0, we're doing it somewhere else. And so whatever that value is, if I want to center it at 17 or -pi/6 or whatever, That's the number that goes in here. This x minus a, x minus that value shifts the graph, just like it did in pre-calculus when you guys did transformations of graphs. So again, one last bit of notes for you today to write down for Taylor series. The other video that I will make, we will go through actually doing this with a couple different graphs, and we'll see what those look like. I will also mention at this point, I'll probably mention it in the other video also, that the AP Central has been publishing videos, and the first few that it came out with were over material that's not covered by the AP test this year, so I haven't brought your attention to it until now. But now there are actually quite a few very thorough, very well, better videos than what I'm producing for you guys. So I put those in a folder on the Schoology page. I'll probably walk you through that process, but just a heads up, watch for that on Schoology. They're not all done yet. They're actually coming out. They're broadcasting them live on YouTube every morning, or at least a couple mornings a week. And so some of the links I have are actually to the what I think are going to be those live videos later on. But I'm going to stop talking on this one, and then I will make another video for later today.